Hello students, good morning all of you. Welcome you all for physics session. And last for a few days I was not feeling so well. Because of that I am not able to upload any class video for you people. Now we'll go with the remaining fact of the first chapter, that is about torque and an electric dipole in an electric field, that is uniform electric field. So first of all, before to start the concept, we will come to know about the meaning of the torque. Torque, as you know, it can be represented by tau. So how do you define the torque? Torque is a product of force into perpendicular distance, or a displacement. Will take that. Okay, so magnitude of force have to consider, and thereafter perpendicular distance also have to take into action. And now you are going to studying about this torque on an electric dipole. So means you require an electric dipole which is of minus charge and plus q charge. So this is what an electric dipole in an electric uniform electric field. So that means that you are placing an electric dipole in such a condition that you are placing an electric field that is uniform. That means uniform electric field is distributed over an dipole, and at that condition what will be the amount of torque? So that is the main funda here. Okay, now so before to start the concept, we'll talk few words on torque. So students already studied about torque in the first VUC, system of particles and forces. We have studied in the first VUC chapter, system of particles and forces. In that chapter we have studied about torque. There we have studied about the stable equilibrium, unstable equilibrium, stable equilibrium, unstable equilibrium. This concept you have studied. So now your job is to study first PUC concepts before to start with the torque on electric dipole in an electric field. Okay, uniform electric field. Have a note on first PUC chapter. Study all these concepts and then move on to this concept. Now, well, students, let us create the uniform electric field here. So we are supposed to placing an electric field. Let the direction of uniform electric field will be in this direction, what I am denoting here. So this will be the direction of uniform electric field direction. At this such condition, if you place an torque what will do? It will rotate. It's a rotational point, no? So I will place like this. Okay, we'll take a minus q charge, we'll take a plus q charge, and this will be center point O. Okay, na? And then as you know, this will be the total distance 2a. We know the electric dipole moment, that is given by P is equal to, what do you mean by electric dipole moment? Let us recall the definition in previous sessions. Electric dipole moment is product of magnitude of either charge or else product of either charge and the distance, that is q into 2a, right? Move on to, so as you know, plus q charge is here, minus q charge is here. So as per the thing we know, plus q direction is in the direction of electric field. So obviously it will move in this direction. Okay, na? So I will write electric field of plus q charge will be plus q into E, if I consider it in vector form, right? And what about the minus q charge? So as you know, the directions will be opposite, no? Hence minus q into E we have to take. Now, first of all, write force on plus q charge, that is F plus q equal to plus q E. Okay, na? And that will be, if you consider the direction, that will be along electric field. Now force on minus q charge, that is F minus q, will be obviously minus q E, that is opposite to electric field. So before to start the derivation, I have cleared the point. The direction of electric field will be in this direction. So along the direction of electric field, plus q charge will move. Okay, so that is the direction of plus q charge. But what about the minus q charge? It will move in this direction. So that will be opposite. Okay, now dipole moment direction, this will be the minus q to plus q charge, right? Now, so first of all, define the torque. So torque of dipole now will be, so the amount of torque is, as I said now, force into perpendicular distance. What do you mean by force here? Force will be Q into E. Okay, I will write the formula. Force into distance. Perpendicular distance will take, so Q into E. Now into perpendicular distance you have to consider. No? Now, dear students, once again I will repeat the statement. Before to watch this video, first go through thoroughly the first PUC concept of torque. Okay, move on to. So here I have plus q charge and minus q charge. Let us note it as A and B. At the same time, I will take the perpendicular components here and as well as the parallel components. Here I will consider in this way, perpendicular. Let us draw our perpendicular DBC. So at this condition, we have angle theta over here. So we have a angle or triangle ABC. ABC is a triangle over here, right? Now on this such condition, I need here a perpendicular distance, no? So at this particular uniform electric field, so that will be BC, QE into BC. So on this point, from triangle ABC, let us define sin theta. So triangle ABC. So for this triangle, define the sin theta. What will the sin theta now? Yes, that will be BC divided by AB. So BC equal to, obviously I will write 2A sin theta. Am I right, students? Because BC equal to AB sin theta. What do you mean by AB? AB is a perpendicular distance 2A. So BC equal to 2A sin theta. Therefore, tau equal to what I can write? Q E 2A sin theta. Q E into BC. BC means 2A sin theta, right? So, on noting this formula, I will rearrange the formula. Rearrange 2QA into E sin theta. Okay, what we can concur here? 2QA, that is nothing but Q into 2A into E sin theta. What do you mean by Q into 2A? Q into 2A is nothing but dipole moment, magnitude of dipole moment into E sin theta. So that is tau equals to P bar into E bar. That is vectorically will write. Keep remember, torque is a cross product. It's a vector. Torque is a vector. Done. So this is what the torque on an electric field or electric dipole in an uniform electric field. That is tau is equal to P cross E. Thank you, students.